Okay, we're going to take a look at slope. We took a look at this today, but it's always good to review. Okay, now we've been working on slope as forming triangles, and I'm going to stick with what we've been doing in class. So I have showed you that slope is nothing more than the angle of a line. And when you form that angle, the angle forms a right triangle. So if we look at the base, here we can see that if you connect, I'm using purple and green. Okay, if you see the triangle here, I just went up 4 units and over 2. So the slope of a line is kind of like the hypotenuse of a right triangle, and we look at this as the height of the triangle. So we're looking at the height of the triangle over, so divide it by, kind of like over. That's my bad line there. The base of the triangle. So we're thinking of this as, like, I always like to think of slope as like a mountain. We know that the height of the mountain really determines the steepness, right? So if the height is more than the base, we know we're dealing with a steep line. Okay, now in this case, our slope is 4 over 2. So if we're looking at the height of the triangle, which we also consider the y, okay, the y-axis is the height. So the height of the triangle would be like the y, and the base of the triangle is the x. Okay, so we can kind of think of it like that as well. Base is the x, the height is the y, and we're just trying to figure out what that relationship is. What is that relationship between the x and the y? Well, if we write it as a fraction, we can see that we have a slope of 4 over 2, which we simplify to equal 2. So this would be a slope of 2. Now, this is using the triangle method. Today, we talked a little bit about how this would look if we used the points instead of drawing the triangle. Now, drawing the triangle is a perfectly good strategy for numbers that are close together, points that are close together. But if your points are really far apart, using the method of subtracting is actually an easier way. So we're going to look at the y's first. And again, I always label my points because I forget. So the second one is the y and the first one is the x. And I do that just to help keep myself organized. I also color code, as you see. So first I want to look at my y's. I have a 7 and I have a 3. So I want to find out how far apart these numbers are. So I'm just finding the difference between the two y's. So I have my y7 and my y3. How far apart? They are 4 apart. Okay, now again, just like I'm keeping it a fraction, so this is my numerator. Okay, my numerator are my y's. So I just did my two y's, y minus a y. So I took two y's, subtract, and then I'm going to do the same thing with my x's. I have a 7 and a 5. A 7 and a 5. These are my two x's I'm subtracting. And I can see that 7 minus 5 is 2. And we got the same answer. Okay, so both strategies work. Both of them work. The subtraction strategy does work, though, when we're trying to prove if a point is on a line. So let's say I want to know, is the point 1116 on this line? Now, I could try to graph it, but if I want to just do a quick proof and just determine is it on the line, I can test it with my equation. I can test it out. Okay, so again, this is my y, and this is my x. Now, I am going to use, I'm just going to use, let's see, I'm going to circle in orange. I'm going to use this set right here. I can use either one. I could use this set of x and y or this set of x and y, but I'm going to go with this one because they're both 7s, and that's a little bit easier for me. So I'm going to set up my subtraction, my two y's, 16 minus 7. And then I'm going to divide that by my two x's, the difference between my two x's. 7 minus 11, or 11 minus 7. 11 minus 7. So I'm going from this to this, from this to this. And I want to see how far apart they are. Okay, so 11 minus 7, that's 4. And 16 minus 7? 16 minus 7 is 9. Ooh. Now, notice 9 over 4, it does not equal 2. It's very close. It's very close, but it does not equal 2. Now, if I were to change this point and say what would work, an 8 would work. 8 would work. So if I made this number 15, 15 minus 7, that would give me 8. So this will not work. Nope. That one won't work, okay? But the 11 works, and 15 would work. So I can say that this one is on the line. So if I replace that 16 with a 15, 15 minus 7 is 8, and 8 divided by 4 is 2. Okay? So this is a really good way to check to see if a point is on the line. So let's see if we can try this side over here. Now this one's a little bit easier because notice it's starting at 0, 0. This one does not start at 0, 0, so we really have to use these 2 points to really help us find the slope. However, this one's a lot easier. Let's stick with our purple and green. Okay, now notice it goes through 0, 0, so 0, 0 is a point. Unlike this, I can't use that point. So this point is on the line, so I could essentially just go over 1, 2, 3, and up 1. So that point right there, that point is over 3, up 1. So essentially that's my slope. Up 1, see there's my 1, and over 3. So I could say my slope is 1/3. Now I know it's a fraction, right? Because it's definitely less than 1. Remember we talked about locating 1. 1 would be like this. 1 would cut all our boxes in half. So that would be like a slope of 1. So this is definitely less than 1. This one's definitely greater than 1, which we knew. We found out that's 2. Now let's just test it with another point. What if I want to go from the 0 to this point? So that's 1, 2, 3. Keep counting. 4, 5, 6, 7, 8, 9. And up 3. 1, 2, 3. So this is a 9, or sorry, 3. Oops. 3 over 9. And notice 3 over 9 is also 1/3. Okay, so this point was over 9 up 3. Now when it's 0, 0, when 0, 0 goes, the line goes through 0, 0, the first point that you come to like that, that is the actual slope, 1 over 3. 3 over 9 is also the slope. We just simplified it. Okay? Now, if we don't want to use this triangle method, we can do the subtraction method. Again, I'm going to label my points. These are y's. These are x's. Okay, so I can subtract my y's. So I'm just looking at my 2 y's. How far apart are my 2 y's? So 3 minus 1. Okay, and then I want to put that over top, or divide that by my 2 x's. 9 minus 3. 3 minus 1. 9 minus 3. Let's see what we get. Okay, so now I'm going to subtract. This is 2. And 9 minus 3 is 6. And you go, wait a minute, Ms. Breen. 2 6, that's not 1/3. Oh, but it is. If I simplify this, this is also 1/3. Okay? Now, if you were to divide this out and make it a decimal, 2 divided by 6 or 1 divided by 3, it's going to be that decimal with that run-on, 3, 3, 3, 3, 3, 3, 3. Now, we don't usually like to use that decimal because it is a repeating decimal, so we usually keep this would be as 1/3. However, 2 6, 1/3, 3 9, they're all equal. Okay? both strategies work for finding slope. However, this one's the best for testing to see if a point will work on the graph. Now, I can come over here and try one real quick. Let's see. I'm going to test one. Let's see if I can find a point on the graph. Let's use this one. Okay, where's my orange? I'm going to use this point right here. Over 1, 2, 3, 4, 5, 6, and up 1, 2. Okay, well, I already know that's going to work, right? Because that's exactly what I found right here, 2 over 6. All right, so that one I can't really test out. I could test another point, though, and plug it in, and just whatever the y is, so we're looking at whatever y is, we're going to subtract by one of the y points. It can be any one, either one you want, the 1 or the 3. And then we're going to divide that by the difference between the two x's. That will give me the slope. Okay, that's going to give me the slope. And whatever that slope is, if we can test any point and just make sure that it works out. In this case, the slope is 1/3. This is 2. Okay? All right, that's it on slope.